Hi everyone, we are back to learning useful Excel functions and formulas for your work as an agronomist. What we're going to learn first is scenario analysis. So we'll have some scenarios that you might encounter in your career and how Excel can help. So with scenario analysis, one really useful group of functions is what if analysis. So you go to the data tab here and you see what if analysis here. We'll click down. There's a bunch of different types of analyses. We're going to learn about goal seek. Before we get into goal seek, I want us to, let's go through the scenario first, and then we'll talk about how to use goal seek. So here, we're interested in renting farmland from a neighbor, and rent is equal to the greater of $200 an acre. So that's like a cash rent, or 25% of the total revenue. So yield times the crop price. So it's either going to be share rent or cash rent, whichever is greater for the landowner. And our scenario here is to calculate the minimum crop price, so dollars per bushel, needed to break even at a yield of 194 bushels an acre. And we'll just use corn here. Doesn't really matter what the crop is. And so goal seek is going to be useful here because we'll set up a formula. We're going to do that right first thing. And then we're going to adjust one of the inputs, which is the minimum crop price. We're going to adjust it based on our a desired output. So here's basically break even, which would be a profit or loss of $0. Okay. So our first step before we get into the goal seek is to write the formula out. And so our profit loss is pretty simple, right? It's our total revenue minus our total cost. Hopefully it's a positive number. So we'll just set the whole formula up, okay? Because that's the first thing we got to do. So revenue here is equal to yield, whatever we put in that cell, multiplied by, so that's a star, by the price, okay? So that is our total revenue, all right? And we can play around here. I'll put 101, right? And, these aren't realistic numbers, obviously, but that's our total revenue. Then we got our total variable costs. So that would be kind of what's called those upfront costs for seed, fertilizer, herbicide, whatever. You can put in whatever number. We're just going to go with $800. Okay. Then projected rent. So what is the rent we're going to pay? Well, remember, it's the maximum, the greater of either 25% of revenue or $200 an acre. So here we're going to go use the max formula, MAX, which is just going to return the greater of whatever two or more things we put in there. So it's going to be the greater of 200, which is the cash rent, or 25% of the total revenue. So 0.25, that would be 25%, multiplied by our total revenue, which is in this cell. So cell C15. Okay, so it's just going to return whatever the greater is. And so we can see here, obviously, the cash rent is going to be higher. Our total cost is pretty simply, it's our rent, whatever that is, plus our variable costs, which I put in $800, do whatever you want. And our profit and loss is going to be equal to our revenue, whatever is in that cell, minus our total cost, whatever is in that cell. And right now we're losing $900, not surprising given it's $1 a bushel. Okay, so now we've set up our formula, right? Because we've linked all our cells. Like this cell is our cell 20 C21, our profit and loss is linked to our revenue and costs, and our revenue and costs are linked properly. So now we're good to start doing goal seek. So remember, the goal here is to figure out at a yield of 194 bushels, so I got to put this to 194, what is the minimum crop price, dollars per bushel, to break even, okay? So break even would be 0, okay? So we're going to go what if analysis. We're going to go goal seek. Okay, so goal seek here, we have three things. We got to set cell to a given value and by changing another cell's value. So we have our formula. We want to set our profit and loss, so we'll click on that cell. We want to set it to $0 because that is break even. And we want to know the minimum crop price. So we're going to only change what cell? We're only going to change this cell, okay? C14. And we're just going to click OK, and we got our answer, okay, $5.50. All right, so if we're expecting 194 bushels, a crop price of $5.50 is required to break even. All right, so that's goal seek. And again, there's two steps. First, you have to get your formula in so all the cells are linked properly. And then once you do that, you're off to the races. You can start with your goal seek. The next tool in our scenario analysis toolbox is data table. And data table, again, you go to the data tab in what if analysis, you'll see data table here. Very, very useful when we want to evaluate. In this scenario, we want to calculate projected profits for a range of different crop prices and yield levels, right? Because in the last goal seek, we were assuming 194 bushels. That's a very specific number. We probably want to check out, what is projected profits, a range of different yields and different crop prices. So everything is the same from the last scenario where we used goal seek. The only thing I changed is variable costs. I put that as $400, which is a bit more realistic for corn production in Ontario. So everything is set up the exact same in terms of what profit and loss is. This is very important. You got to set up the formula the exact same. And we got the projected rent, the max of 200 or 25% of the total revenue. Okay, so we've set up our formula. That's the first step. And then we're going to go to our data table. This is also called a sensitivity analysis because we're looking at projected profits, how sensitive it is to different prices and yield levels. So the first thing you got to know is in the top left corner of your data table, I grayed this box out. You want to click equal to and then your profit and loss, because this is telling Excel like what formula are you going to be manipulating, and you want it to be equal to kind of the output, the formula output, which is all the way down here. All the cells are linked to this profit and loss statement. So we'll put that here. Okay, so once that's done, we're going to fill in the rows and we're going to fill in the columns. So we'll do the columns. Doesn't really matter, but we'll do columns as the crop prices. So we'll start at, $5 and 20 cents a bushel, $5.30, $5.40, $5.50, $5.60, and $5.70. So these are our potential bushel prices. Then let's just go yield. Let's just do 170. 180, 190, and so forth. Okay. So once you've done that, we're basically ready to roll here. We have our potential prices in the column. We have in the rows our potential yield levels, and we have our data or the formula being referenced up here. So we're going to highlight all of this. Okay, that's the first step. Then we're going to go to what if analysis and click data table. So data table is going to say, okay, what's in the rows? Like I see the formula you're manipulating. What is in the rows? Like what part of this formula is the rows representing? And it's representing yield level. So we're going to go here and click on column D9 so that Excel knows that that's what we're referring to as yield level. The column input cell is our crop prices. So we're going to click this up arrow and select price. I'm going to go OK. So we've set everything up. We've told data table we want to manipulate this formula. In the rows is our yield. In our column is the price. We're going to click OK. And then we get a whole range of different profit levels. Okay. And that's it. Right? So then you can kind of look through and use some risk analysis. Okay, what is my potential profit here? Okay, so now we're going to learn about conditional formatting, which is in the Home tab, not in the Data tab. Bit of a nice change from previous Excel things we've been learning. And what it is conditional formatting is a way to color cells based on rules you give Excel so you can easily visualize what's going on. As opposed to having to read every single cell. So let's just go through our analysis, and it should be fairly straightforward how this works. So we have profit and loss calculated across different management zones of a 200-acre field. So we have our management zones here, we have our revenue expenses, and then our profit and loss. And we want to just visualize easily which zones lost money, which zones made more than $100, which profited between $1 and $99. So we're going to do this really simply. We're going to give it 3 rules to conditionally format, and you'll see what's going on. So we click conditional formatting here, and we're going to say highlight cell rules, and we'll start off greater than 100, right, which profited more than $100. So we're going to format cells that are greater than. We'll just write 100, and we're going to want to give that, let's give that green, okay? So more than $100. Click OK. And we already have our cells that are highlighted. We'll just keep going. We'll highlight these guys again, go conditional formatting, highlight cell rules. We'll say between, and we'll see between it was $1 and $99. Okay, and we don't want to make that red. Let's just make that yellow, let's say. Okay, and now we're going to just go again. This is not too complicated. We're going to go less than, because we want to see which lost money, less than 0. Okay, and we can keep that red, or we can do custom, where we can say, okay, we want the border to be a given color. I don't know, let's just make it purple. Let's say we want the fill to be orange. Click OK. And OK. So now we have a purple. I don't know if you can see that, but it's purple and orange. So you can go nuts with the conditional formatting rules. Very useful. Now we're going to learn the XLOOKUP function, which is probably my favorite Excel function, if I'm going to be honest with you. It's great in these kinds of scenarios where you have two different data tables here. Right now they're side by side just for ease of the example, but they can be in different spreadsheets. It'll work just the same. And you want to combine data from these two tables. And this is great when you have really big data sets where it's like you just don't want to copy and paste. You want something automated that will not do any typos. Now, what you need for XLOOKUP to do this, to take data from one table and put it into another, is a common identifier. All right, so here, field ID is that common identifier, and you'll understand what I mean as we run through the scenarios. Okay, so this scenario is you have your agronomist sends you data on the average yield for each of your fields, okay, and your accountant sends you data on the net revenue from each of your fields. And I want to combine these, right? I want in this table that I got from my accountant, I want to copy the correct yield for each of my fields. And again, so much data, I'm not going to copy paste. But luckily, we have this unique identifier, and so we can do an XLOOKUP. So let me just zoom in here, and we'll get started. So we're going to go equal XLOOK, XLOOKUP. You can just press tab here. So first is the lookup value. So here I'm looking for yield of field 1676. So I'm going to click E6. That's what the lookup value is. And I'm going to comma. So next, I have to go to the table I want to copy from. So the first thing I'm going to copy is my lookup array. That's the unique identifier. So it's going to basically look in the lookup array for this unique ID, 1676. So I'm just going to copy and paste that. Just drag that down. Bring that up. Now I'm going to lock my cells because that'll make it easy to copy and paste when I do that later. So I want to lock that up. And then my return array. So XLOOKUP is going to look up the field ID and what do I want it to return. So here it's very obvious because there's only one column, but if there was lots of different columns in this data we got from our agronomist, we would just highlight the one we're looking up. So we want it to return for that given field ID whatever is in this column. And again, we're going to use our dollar signs before the column, before the row to lock them. That'll just make it easy as we copy and paste. Now, we won't go through the next fields in this formula, but for example, there's if not found. So this is just what to return if not found. And you can just be like, you can put in anything you want, not found. And if you're using text, again, you got to use quotation marks. Okay. So here we got our lookup. So field ID, we got our yield, and we can just copy and paste. And if there's a cross here, if I hover my arrow on the bottom right corner, I can just drag and drop. Ooh. And I overshot here, but you can see it's not found, right? That's what it will return. So, you can do this yourself. I'm just going to highlight this here so you can pause the video. It's a great function. So in our next scenario, we're going to be learning how to do drop-down lists and combining that with XLOOKUPs to make, I think, something that's approaching like actual being useful, an actual useful or realistic scenario. So let's say here we're a no-till farmer. We're buying urease inhibitor to mix with our urea fertilizer. So we can incorporate our nitrogen. So to reduce volatilization loss, we're going to broadcast urea that has an inhibitor applied. And we want to calculate the per acre urease inhibitor cost for our fields based on the inhibitor product used and the amount of urea where we plan to apply. So what we have here is our urease inhibitor products. These are actually all, most of these are real. And we have the price per ton. So that's normally how these urease inhibitors are priced. It's like per ton of urea. And you would mix that in with the urea before you apply. So first, we're going to learn drop-down lists, and you're going to see how we're going to combine these things. So first, we have our drop-down list for our inhibitor type. So first, we're going to go to click on the cell. We're going to go to the data tab up here. We always typically work in this tab. And we're going to go to data validation. That's what we're doing. And we're just going to click data validation here. And we want to allow not any value. We want to allow a list because we have our list. And so what do we want? We're going to pick the source. We're just going to click that guy. And this is our list. And so the data validation, we're just going to go back. We're good. We click OK. We have this little drop down here. The data validation won't let us put anything into the cell other than what's in this drop down list. All right. And you can copy and paste. So I'll just say copy and then I can paste. Right. I'm just pasting that. But again, I'll just do it one more time. You click on the cell, you go to data validation, click data validation, and we got our list here. So you would just highlight the list you want. All right. So we have our inhibitor types here. Pretty cool, right? This makes you look really impressive. Now we're going to do something pretty interesting, which is we're going to use XLOOKUP to do one thing. It's going to return the price per ton. And then we can use what XLOOKUP returns, this number, and we can actually calculate the total inhibitor cost. I just want to go here because I'm a little bit pedantic here. There we go. I just want the outside borders to all be equal. Okay, so we're going to do XLOOKUP. We're going to get the price per ton. We're going to get the field size and the tons per hectare. Okay, so let's just first start off like with our tons per hectare. So for example, here we have a 80 hectare field. We're using this many tons per hectare. And let's just close these in brackets. That'll keep our formulas really nice. So this is actually what we want it to look like. Right now it's a cost, but that's not really a cost. That is just the total amount of urea we're going to use, right? The tons per hectare times the number of hectares. That's basic math. So we have our total urea rate, and then we're going to multiply that by our XLOOKUP values. So we're going to go XLOOKUP. Here we go, XLOOKUP. Now, what do we want to look up? Pretty simple, right? We're looking up the inhibitor type from our drop-down list. Our lookup array, we slide down over here. This is our lookup array. We want it to, this is the unique identifier. Then what do we want it to return? Well, we want it to return the price per ton of that urease inhibitor product. And we'll just close bracket, but you can see this is how it's set up, and this is how it works. Click enter, and bada bing, bada boom, we got our total inhibitor cost. And we can easily just copy and paste this as long as we lock our cells. Remember, you got to put those dollar signs when you're copying and pasting formulas because we don't want to mess things up. All right, so that's it, right? That's it. Pretty cool. Okay, guys, this is the final XLOOKUP scenario, I promise you. It's just a lot of fun. You know, I love XLOOKUPs are fun. Okay, so what we have here is revenue across fields, and this should be years. Revenue across fields and years here. So we have everything's in Canadian dollars, and this is our revenue, right? And let's say we want to make a nice little Excel spreadsheet where we can just select the field and the year and get the revenue for that field and year. So we're going to, again, combine our drop-down data validation lists with XLOOKUP. So we'll do data validation here for our field. You guys know the routine. We're going to not allow any value. We want a list. And for field, we only want these fields. So we just highlight that, click OK, and then bada boom, bada bing. Same for years. We're going to do data validation. We don't want to allow, we want we only want years from this list here. So I highlight these cells, B10 to H10, bada boom, bada bing. All right, so we're good here now. Let's just choose, I don't know, doesn't really matter here, berries in 2020. So we want to be able to look up berries in 2020 without having to do this manually. So, you know, it's this, but I have to use my eyes and it's a little confusing. So we're going to do an XLOOKUP here. All right, so we're going to go equals XLOOKUP. And the first thing we're going to do is look up the field. So this is the unique identifier. We want it to look that up. This is the lookup array. And now what's the return array? Well, this is what we're going to do. We're going to do another XLOOKUP in the return array. We're nesting an XLOOKUP in the XLOOKUP. So in the return array, we're going to do another XLOOKUP. We want the year here. And so that is our year we want. Okay, the lookup array here is this guy. Okay, lookup array. And the return array, now what we're going to highlight, now that we set this up, we're just going to highlight in here, cell B11 to H18. So we're basically highlighting the data in the table, the dollars in the table. And so we're going to go close bracket and then another close bracket, and we're going to click enter. And that's it. Okay, let me just, let me zoom in here so you can see, pause to see what's going on here. But this is great because I can just go, I don't have to be looking up things. I can just pretty easily figure out revenue. So very useful, makes it look like a genius. Okay, so now we're going to be back to our logical operators, the same kind of family of functions like if statements, but now we're going to be learning about and or functions. Now, these are logical operators, which just means they return true or false, right? They don't give you a number. They either resolve to true or false. So this is very common in computer programming, these kinds of functions. So with an and statement, okay, an and statement resolves to true if every single condition in that statement is also true. An or statement will resolve to true if at least one condition is true, which is different. Okay, and what do I mean? This is all very vague. Let's just, before we run through the example, let's just go right here. Okay, so we have our, okay, so let's just say we're going to have an and statement here, so and formula, and our first logical condition is that whatever this number is, yield potential has to be greater than 90, all right? And that's our first logical condition. And let's say our next logical condition is that our soil test phosphorus parts per million has to be greater than 31, okay? Now, we have two logical conditions here. K3 must be greater than 90, which would be true. J3 has to be greater than 31, which is false. So this whole statement, I'll just click enter here, will resolve to false. Okay, but let me turn this into, instead of 30, I'm just going to turn it to 40. Right? All of a sudden, this and statement will resolve to true because guess what? Both of these things are true. Okay, I'm just going to return this to 30, and now this is false. Oop, what did I do there? So let's go back here. This is the original data set. So this is an and statement. Both of these things must be true to resolve to true, but they don't because it's false, just as a reminder. Now let's do an or statement. So I'm just going to highlight A and D and just replace it with or. Now, only one of these things have to be true, not both. And one of these things is indeed true, so when we click enter, we resolve to true. So that's the difference between an and or statement. Okay, I'm just going to delete that. And now let's go to our scenario. So you're deciding whether to apply monoammonium phosphate, which is an expensive fertilizer, to your field zones, and you'll only apply if both of the following are true. So soil test P has to be less than 15, so you have to be deficient in soil test phosphorus, and yield potential is greater than 90 bushels per acre. So that can be historical yield, say. So we're going to develop an if statement to automate that decision making, right? So we don't have to look and decide. We can just do an if statement. So we're going to start with equals if, and our logical test, well, are we going to do an and or an or statement? What do you think? We're doing an and statement because two things have to both be true. Soil test P has to be less than, 15 parts per million. So that's the first thing. Oh, and by the way, less than is different than less than or equals, right? If it was less than or equals to 15, I'd have an equal sign over here. But it's just less than 15. Pay attention to that, by the way, in questions. So it's less than 15, and then yield potential has to be greater than 90. Okay, so that is our and statement. So this will resolve to true or false. Done. So we put a comma here. We're back to our if test. So if the logical test resolves to true, we'll just say, apply map. And if it doesn't, do not apply map. Why not? I don't know. You could write whatever you want. Remember, because you're using text, you got to use those quotation marks. And there we go. So we can easily copy and paste here. We just highlight the lower right corner of the cell, double click, and you can see we're applying map only where we have low soil test phosphorus below 15 parts per million and high yield potential. Okay. All right, so now we're going to our next and or scenario here. We're getting crazy with it. All right, so here we're also deciding whether to apply monoammonium phosphate, an expensive fertilizer, but we now our decision rule is a little different, right? We're going to apply MAP to our field zones if at least one of the following two decision rules are true. So the first one is the same as the previous example: low soil test phosphorus below 15 and yield potential greater than 90 bushels. But we have a second decision rule, which is yield potential is greater than 140 bushels per acre. So here it's like a very high yielding zone, and we really want as high yields as possible. So we're just going to add phosphorus anyway to those areas. Okay, so what's the logical flow here? There's a couple ways to do it. The way I'm going to suggest is you nest everything in an OR formula. So you have an OR statement basically. And in your OR statement, you're going to nest an AND, right? So you're going to have your two decision rules nested in the OR formula. Decision rule A will be an AND statement, and decision rule B is still in the OR formula because very simple to do. So let's get started here. Let me zoom in a little bit. Okay. So we're going to start off with our trusty if statement, if, open bracket. The logical test is an OR statement. So our first logical is actually an AND statement. So basically, the first thing here is that this must be less than 15, and this must be greater than 90, right? Our yield potential is greater than 90, and soil test is below 15, right? So this, and then we'll do comma, right? So here in our OR statement, this whole thing will resolve to true if both of these conditions are met: low soil phosphorus and yield potential above 90. The next part of our OR statement is just simply is yield potential greater than 140 bushels per acre, okay? And before I keep going with the if statement here, this is a little complicated, but understand there's an OR statement here. An OR will resolve to true if this thing is true, the AND statement, which we did last scenario, or if this thing is true, it will also resolve to true. So let us keep going here. Comma, back to the if statement, value if true, we'll say apply map. And why can't I spell? Here we go. And then don't apply map in quotation marks. And close bracket, we are done. Click enter, and we will just copy and paste that down. You can hover and double left click here, and you can see that this is applying map in high yield potential zones even when soil phosphorus is high. So very, very useful to nest this. I'll just zoom in again so you can see the statement. Oh man, come on, here we go. So you can have a look at what's going on. All right, so this is another AND and OR example that's a bit more complex. It's more realistic in the sense of it's more more applicable and more useful for day-to-day work, something you might potentially use in your future. So we're going to use if statements, AND statements, and OR statements here. Let me run through the scenario. So this is essentially a decision support tool for fungicide applications. Essentially, this is true in corn and most crops. If you see symptoms of a disease, of a fungal disease, it's too late to apply the fungicide. You have to apply the fungicide before symptoms of the disease show up, basically before you know 100% or not if the disease will be present. And so this decision support tool is basically going to give you a, apply or don't apply based on risk. So there's kind of two things that have to be true. First, the weather has to be conducive for fungal infection. And next, at least one risk factor has to be present. Okay, so the first kind of weather decision is, 7-day forecast. It has to be more than 40 millimeters of rainfall in the 7-day forecast and average temperatures between 18 and 27 degrees. Exclusive. Exclusive just means between 18 and 27, but not including them. So if it was 18 degrees, that would not count for this. So that's weather. You have to have a certain amount of rainfall and temperature, and then at least one of the following risk factors must be present. Either the previous crop was corn, so it's a corn-on-corn situation. If the current hybrid that's planted has a high susceptibility rating, which you can obtain those from the Ontario Corn Committee. They'll have susceptibility ratings as well as the breeding companies. and the field if it has a history of disease, like if in previous years there was a disease present. Okay, so if at least one risk factor is true and the weather is conducive for infection, we'll apply a fungicide. So what I did here for the risk factors is I just made some conditional formatting just to keep it easy, because when we do if statements, we're going to need like the precise words. Okay, so I have the conditional formatting. Okay, so the way we're going to do this is in basically 3 steps. First, we're going to do an if statement for the weather, right? Then we're going to do an if statement for the risk factors, and finally, we'll do an if statement that both the weather has to be conducive and at least one risk factor is present. And if that's true, then the decision rule is to apply. Okay, so I'm just going to put in some numbers here. I'll do 41 and 20, so that would be conducive. Okay, so we're going to do an if statement. If. That's the first. Actually, let me zoom in here. Just make it easier for you to see what I'm writing here. So we have if open bracket. Now, the first logical test, we're going to do and, because 2 things have to be true, right? We have to have high rainfall and temperature. So we're going to do and D. The first logical is this is greater than 40, right? That's pretty simple, comma, to the next logical statement. Now, the next logical statement is the temperature has to be between 18 and, 18 and 27 degrees Celsius. The way we do something like that with an and statement is we actually need 2. We need this has to be, so D11 has to be greater than 18. And remember, if it was inclusive, it would be greater or equal to, but we're doing exclusive, so greater than 18. And this also has to be less than, 27, right? So that is our and statement. All of these things have to be true, right? Rainfall has to be greater than 40, so D10. And our temperature at D11 has to be greater than 18, but less than 27. So let's go back to our if statement. We're done our logical test, comma, and so value if true. So if all of these things resolve to true, we're going to say, yes, you should. And if it resolves to false, quotation marks, no. All right. So as you can see here, it is yes, but we can easily I'll just change this to 30, and that will turn to no. I'll put that to 20, and then let's do 39. No. Okay, so this is working pretty good. Now we're going to be doing our next if statement, which is essentially, is one of these risk factors present? So this is an if statement, but we're going to use an or instead for our logical test. So our logical test is or, okay? And so one of these things have to be true. So this has to equal, and because we're using text, we're going to do quotations, yes, right? Next is the current susceptibility high. This has to equal, and we have to use quotation marks if the logical, if the or statement is dependent on text. And this has to equal, and then yes. All right, so that's our or statement. One of these things have to be true. That's what or means. Comma, our value if true, yes. And value if false, no. And then close brackets, we're good. So let me just play around with this. Low, I'm going to put no. Notice that it's still yes, the fungicide, but we're just going to choose this to no. And all of a sudden, this becomes no. Okay. Now we're going to go finish this thing off. Should a fungicide be applied? And remember, both of these things have to be true. So I'm going to do another if statement here, and then our logical test is and, right? Hopefully you guessed that. This has to be equal to yes, and this has to be equal to yes. All right, it's not rocket science, but it can be a bit confusing. So let's go back, quote to our logical, value if true, apply. And value if false, we'll just comma to value if false, do not apply. Okay, so Let me zoom out here a little bit so you can see how this is working. Hopefully you've been following along, but let me just go here and then I can switch this and then all of a sudden we're going to apply. So hopefully this is helping you understand how we can put these statements together to make something that is approaching, usefulness in real life. Okay, everyone. So now let's go through the homework, the actual deliverable for the lab. It's basically a more complicated, more realistic decision support tool for fungicides that we just did. So, the very high level, there's a couple of steps here. Now, you're going to have to determine should you apply a fungicide based on weather and risk factors, very similar to what we did before. Okay. Now, there's an extra step here or something else, which is that you'll only apply a fungicide if the expected net return is greater than 0, and you also have to decide which is the most profitable fungicide to apply. So you have to say, should you apply a fungicide or not? And if you do apply a fungicide, which one should you apply? And so we have fungicide A and B here. They have very different fungicide costs per acre, and so their returns will be different. Another part of this homework, as you'll read through it, you'll understand, is you also have to determine if disease is expected or not expected to happen. And the reason is that will determine your your expected financial return. For example, if you expect disease to occur, right, the yield gain from fungicide A and B are similar, 7 bushels per acre versus 6, but the cost here is very different, right? It's 18 versus $9 an acre. And in compared, when you don't expect a disease to occur, you still may apply a fungicide, really based on expected net return. So, long story short, okay, all the yellow cells are where you'll be putting in formulas. And I don't want you to hard code things. I want this to be formulas, and I will be checking your formulas. I will be kind of playing around with the numbers, and basically I'll be playing around with all the inputs, which are the gray cells. All right, so the gray cells are what I'm inputting, and the yellow cells are basically where you will be putting in your formulas. Okay, so have a read through the scenario, but basically these are the steps, right? Based on weather and risk factors and expected net returns, should you be applying a fungicide? If you are applying a fungicide, right, is this a situation where disease is expected or not? And then based on all of that, which fungicide should you be choosing, A or B?